So this video we will be discussing May-June 2025 paper 55 for statistics, probability and statistics 1. Okay, question number 1. We are given 5 6-sided dice and they are fair dice, okay? Then with the faces labeled 1, 2, 3, 4, 5, 6, they are thrown. The two scores are noted. The random variable x is defined as follows. So there are two scores. If let's say the two scores are equal from both dice, then it will be x equals to 0. If the score are not equal, then x is the larger score minus the smaller score. Okay, draw a probability distribution table for x. Okay, to draw the probability distribution, there are many ways for you to figure out how to get the value of the x and also how to get the probability. So for me, because of I know that we are throwing two fair 6-sided dice, then to me, the more suitable way is by using the possibility space diagram. I will use possibility space diagram because it will show me all the possible results in the experiment. Okay, then of course some students they might want to just list out all the possible outcome. Also can, up to you. All right. Yeah, so I will try to draw a possibility space diagram. Personally, I like this method very much because in my opinion, although it is a bit time consuming to set up the method or the step, but actually it is very safe because it will show every possible outcome for the experiment that you are trying to carry out. So to me, I really like the method. But the bad part is maybe the down part is because of you need a longer time to set it up. Okay, to set up the step. Alright, so I'm having two dice here. I'm having dice number 1 and dice number 2. The result of dice number 1, I can get 1, 2, 3, 4, 5, 6. The result for dice number 2, I can also have 1, 2, 3, 4, 5, 6. And where are the outcome for throwing the two dice? So the outcome will be all the boxes here. So if you try to count, there are 6 times 6 boxes, which is 36 boxes. Okay, so there are 36 boxes here. And if I fill in all the result in the boxes, later I will know what are my outcome for the experiment. Okay, then for this question, because they say that if the two scores are equal, then x is equals to 0. That means when you're having first dice is a 1, second dice is also a 1, then your score is a 0. So simply happen for 2 and 2, 3 and 3, 4 and 4, 5 and 5, sorry, 5 and 5, then 6 and 6. Okay, then after that, for this particular cell here, the score are not equal, right? So what is the score for the x? You will take the larger score minus the smaller score. Therefore, for this particular cell, it will be 2 minus 1, which is a 1. Then for the next cell, it will be 3 minus 1, which is a 2. 4 minus 1 is a 3. 5 minus 1 is a 4. 6 minus 1 is a 5. So this is how I fill in all the possible outcome for the experiment that we carry out here. Okay. Then simply happen for this particular cell, it will be 3 minus 2, which is a 1. Then 4 minus 2 is a 2. 5 minus 2 is a 3. 6 minus 2 is a 4. Then you try to complete the whole table by filling in a suitable value for the cell. Okay, so 6 minus 5 is a 1. Simply happen here, 2 minus 1 is a 1. 3 minus 1 is a 2. 4 minus 1 is a 3. 5 minus 1 is a 4, and so on. Okay, so you can see that although it is maybe a bit time consuming, right? Because you have to fill in all the possible values. Okay, but to me, all the 36 outcomes here already will be the answer. Okay, it already shows all the answer here. But of course, we have to put our answer into the probability distribution table. Okay, so first of all, let us figure out what are the possible value for the x that we have in carrying out this experiment. So all the blue color number will be the value of the x. You can see that x can be equal to 0, can be equal to 1, 2, 3, 4, until 5. There's no 6 here, right? Yeah, so I know that my value for the x can be 0, can be 1, can be 2, then 3, 4, 5, and 6. Oh, sorry, there's no 6. Then now for the next column, next row, I want to put in the probability of every single value of the x. And how to get the probability here, you just try to count how many times 0 appear in the blue color cell here. So you can see that the 0 actually appear for 6 times, right? 1, 2, 3, 4, 5, 6. So it will be 6. over what is the total outcome that you have here. 6 times 6 is 36. So you're having 6 over 36. If you want to simplify the answer also can. Alright. Yeah, so we repeat the same process for all the other value for the x. So when x is equals to 1, just try to count and you will see that you're having 10 times of the 1. 1 appear for 10 times, then the probability will be 10 over 36. Then for the 2, try to count again, you're having 8 over 36. Then for the 3, you count, you'll have 6 over 36, then 4 over 36, and also 2 over 36. After I try to fill in all the probability already, then to double check the final answer, what I do is that usually I will double check. I add all the probability together and see whether is it equals to 1. If the summation of the probability equals to 1, that means very likely your answer should be the correct answer lah. Okay, but if let's say when you add all the probability together and you didn't get the 1, that means definitely there's something wrong in your calculation. Okay, yeah, so this is just a small way lah for us to check whether your P is correct or wrong, right? Yeah, and we have this answer. This is our probability distribution table for x. Then of course some students will say that should we actually try to simplify? You want to simplify also can. Alright, without simplifying also can, no problem. Because for marking scheme, you can see that they actually accept all this value here, right? Okay, this is what you have for part A. Then let's continue to part number B. For part B, what they want us to do is find the expected value of the x and also the variance of the x. Okay, to find the expected value of the x in a probability distribution table, you need to take x multiply with every single probability and you add them together. So it is basically summation x multiplied with the p. After that, I will usually tell the students, if you can, you try to find ex squared first. What's the meaning for ex squared? That means you are taking the x squared multiplied with the probability and you add them together. So that's ex squared. After that, only you try to figure out the variance x. And the formula for the variance x is ex squared minus the mean square. Okay, and we are going to apply it now. Right, so before that, maybe I try to drag our table a little bit down so that you can refer to it. So like what I told you, this is our answer for first part, right? Yeah, then by referring to the table, let us try to figure out the expected value of the x. Okay, according to the formula, we are having x multiplied with the p. That means you have to take x equals to 0, multiply with 6 over 36. I don't write it out because 0 multiply anything also a 0. So I proceed to the next value of the x. When x is equals to 1, okay, then you are taking 1 multiply with the probability 10 over 36. Then repeat the same thing for the rest of the value of the x. So when x equals to 2, multiply with the probability 8 over 36. When x equals to 3, multiply with the probability is 6 over 36, and so on. Okay, when you try to multiply everything together and add them together, by right you'll be having 35 over 18. Or if you want to make it become 3 significant figure, it should be 1.94. For me personally, I prefer the fraction form, okay, because later I'm going to use it in calculating the variance also. So the fraction is important, right? Yeah, then let's continue for the next one. Before I found the variance x, I have to find the ex squared first. So for ex squared, it is x squared multiplied with the p. So that means 1 is the x, right? You square it first, multiply with the probability 10 over 36. Repeat the same process for every single value of the x. So 2 square multiply with 8 over 36 and so on. Okay, then after that, when you try to get the value for ex squared, by right you will get 35 over 6. Okay, and please take note that this is not your final answer for variance x yet, yeah? Okay, to get the variance x, you have to continue for one more extra step here, where you are taking ex squared minus the mean square. So please use 35 over 18. Then you square it. Okay, and what do we get here is we will be getting the variance x equals to 665 over 324 in the fraction form. If you don't like this, then you can correct it to 3 significant figure, which is 2.05. And this is a value for the variance of x. Okay, so a small reminder here, when you are trying to calculate the variance x, right, please use the original fraction for the expected value of the x, but don't use the summarized or simplified answer. So don't use 1.96 here. Okay, so you need to know that you have to substitute the original value for the mean when you are using it to calculate the variance here. Right? Yeah, so this is how we solve. Okay, question number 2. The height of trees in a certain forest are classified as tall, medium, or small. The height can be modeled by a normal distribution. So please highlight the keyword normal distribution. The mean is given, standard deviation is also given here. Trees with a height of less than 14 meters are classified as small. For 150 chosen trees from the forest, how many would you expect to be classified as small? Okay, to get the number of trees that's classified as small, first of all, we need to calculate the probability that the tree is small first. Alright, so from here we know that the height of the tree is x is normally distributed with the mean 20 and also the standard deviation 5. I need to put a variance here, therefore I have to put 5 squared. Then we need to find out the probability of x smaller than 14 first. Because when x is smaller than 14, it is classified as small, right? Okay, so the probability of getting the small tree is x smaller, small tree is x smaller than 14. Okay, this is a normal distribution. To get the probability, you have to standardize your x become the z. So please take the x minus the mean divided by standard deviation. And the value of z that you get from here should be equals to negative 1.2. Okay, and after that, to find out the probability here, we are interested to find out the probability for z smaller than 1.2 negative. So that means you are interested to find out this particular area. To find out this particular area, we can't get the negative value of z in the table. So we are trying to see this area particularly same as which one? So it is basically same as the area where it is z greater than positive 1.2. And to get z greater than positive 1.2, you have to take 1 minus the probability of z smaller than 1.2. And this is the value that you can get it from MF19 in the normal table in the MF19. Okay, then let's continue further. Z smaller than 1.2. So let's go to the table looking for the value of 1.2 and what is the probability? The probability is 0.8849. Okay, and we have to put it here 0.8849 and we take 1 minus because we're interested to find out z greater than 1.2 or z smaller than negative 1.2 because these two areas are the same. The graph are symmetrical, right? Okay. Then when you try to minus it, you'll get 0.1151. This is the probability of getting the small tree. But in this question, they're asking for the number of the tree. How many of the tree? Okay, so they are talking about the number of the tree. Therefore, to know the number of the tree, you have to take the total number of tree that we have 150, multiply with the probability 0.1151, and you'll get the decimal number 17.265. Then of course the tree must be in integer, right? Then usually you can either round it up or round it down. For me, 17.2 is closer to 17, so I'll just keep it as 17 trees. Alright, yeah, so this is what you have for part A in question number 2. Then let's continue to part B. Now they say trees from this forest are classified as tall if the height is at least h cm. 25% of the trees are classified as tall. So find the value of the h. Alright, so still the same. It is still talking about the height of the tree. It is still normal distributed. And the mean is still the same, where it is still 20 and the variance is 5 squared. And now from here, I know that the probability of x greater equals to h. When they are saying height is at least h cm, convert into a symbol, you'll be having x greater equals to the height. And then what's the percentage of the tree that is greater or equals to hm? So it should be 25%, which is 0.25. Okay, right, then again, for this question, because I know that it is normally distributed, so to find the probability, I have to standardize it first. I'm taking h minus the mean divided by standard deviation. And what do I get here is I'm getting 0.25. And now I need to find out this value of z in our formula here. To find this value of z, I need to apply use the normal distribution table in the reverse way. But before that, I try to figure out first how my graph look like for this particular equation. Okay, it is a normal graph here, and then they say that z greater than this value is equals to 0.25, which means that if I try to draw it in a diagram here, 0.25 is a small area, right? So it should be 0.25 here. Greater means that you have to shade the area on the right hand side of the line, and this value will be the value of the z. It can be also h minus 20 divided by 5, because in our equation it says that when z greater than this value, the area is 0.25. Okay, right, so how can we find this particular value of the z from the table? You can find out the table using reverse way. The area here, 0.25, is a small area. If we have a look for our table, right, all the area are this part. All the value of the z is this part. So area here, you need to look for 0.25. Can you see any 0.25 in this particular part here? No, right? Because the smallest value is 0.5. Therefore, when you're having a small area, to find out the table in the reverse way, you have to use the complement area, which is 0.75. Because 0.75 plus 0.25, you'll get the value 1, right? Total them out, it is equals to 1. So this is why I call it as a complement area lah. Right, so try to use the complement area 0.75 to find the value of the z. Where is 0.75? So please look for a value less than 0.75 but closest to it. And according to what I have here, I think this is the closest value lah. 7486. How can I make it become 75? You have to add 14 at the last two digits of the number so that you will get 7500. Okay, then at the same row, looking for 14. Is there any 14 at the back? 0.67. There's no 14 here, right? Yeah, so if there's no 14 here, then how? You just try to choose a value that's closest to it. So 13 is the closest to 14. Okay, therefore, if I try to read out the value, it should be 0.67, then 4. Alright, then in my solution here, I know that this value basically is 0.674. And according to the diagram that I draw, okay, you know that the center line, the mean, is equals to 0 in the standard variable z. And this particular value of the z is after the 0, which means that this value of z should be a positive value. Therefore, it should be positive 0.674. Then you try to compare these two values together because they are the same. They should be the same. Right, so compare these two values together. Then this is how you get the value of the h. So I take h minus 20 divided by 5 equals to 0.674. What's the value of h eventually? Okay, you try to move all the number to one side, you'll get h equals to 23.37. Then of course, we are going to correct it to 3 significant figure. Therefore, the h should be 23.4. Alright, yeah, so this is how we solve question number 3. So question number 3. In a certain large school, on average, 2 pupils in 5 have music class or music lesson. Okay, from this particular sentence here, basically I know that the probability of having music lesson, right, for a student is actually 2 out of 5. So 2 over 5. Okay, and now you're having a random sample of 80 pupils. Then use an approximation, highlight the keyword approximation, to find the probability that fewer than 27 pupils have music lesson. Okay, there are a few important keywords here. So first, try to highlight the keyword approximation. In our AS syllabus, we are having only one type of approximation, which is binomial changing to normal. So they already give you a very obvious keyword, yeah? So binomial originally is n and p. Then you try to change become normal, which is mean. Mean is n times p from a binomial distribution. Then the variance is mpq. Okay, so this is what you need to know when you are trying to change a binomial become normal distribution. And besides that, because we know that binomial is discrete random variable, normal is continuous random variable. Therefore, you have to do some adjustment when you are changing a discrete random variable to continuous random variable. And the adjustment should be we call it as continuity correction. And usually the continuity correction, the value that we take is either plus 0.5 or either minus 0.5, depends on the question. Okay, right. And since we already know that this question originally it is binomial, so let us write out all the parameters first. X is binomial distributed. I'm having 80 pupils in total. The probability of having music lesson is 2/5. And I'm going to change it become normal distribution. The first parameter in normal distribution is the mean. How can I get the mean? So you take n, multiply with the p. So n times p, you should be getting 32. Okay, so n is 80, p is 2/5. Multiply them, you get 32. Then for variance, it will be n times p times q. So 80 times 2/5, q will be 3/5. When you multiply them, you'll be having 19.2. Okay, so it successfully changed binomial become normal distribution. Then let's set up the question here. I want to find the probability of number of pupils fewer than means less than, no equal sign, 27. So this is binomial distribution. Before we can continue to calculate the probability for normal distribution, you have to do some adjustment first, which is the continuity correction. What's the value for the continuity correction here? Should it be 26.5 or should it be 27.5? Okay, so let's have a look here. I try to label some value here. For binomial graph, it looks like a vertical line graph. And then I'm having a few value for the x, so you can maybe try to find out 25, 26, 27, then 28, 29, and also 30. Let's have a look for the question. We are looking for x smaller than 27. But the 27 has no equal sign, right? So 27 itself is not included in your calculation. Therefore, when we try to figure out the area that I want to find or probability that I want to find, we are starting from 26 and below. The continuity correction value should be the line that is slightly behind, okay, the area that we want to find. And according to this graph, you can see that the value between 26 and 27 will be 26.5. So the continuity correction here should be 26.5. Okay, this is the step of finding out the continuity correction. After that, I have to make it become the z before we can find out the probability. So I take 26.5 minus the mean. Mean is 32 in this case, right? Divided by standard deviation. So what is the standard deviation here? Square root 19.2. Okay, use calculator to help you and get the answer for the z. By right, you should have negative 1.255. Okay, then there's a small suggestion or reminder here. Your value of the z correct to 3 decimal places. Okay, because the accuracy in our table is up to 3 decimal places for the value of the z. Okay, then after that, you can try to draw the diagram whatsoever to see which area same as this one. So I know that this area same as 1 minus the probability of z smaller than 1.255. And now I want to get the value for this one. I can get it from the table, 1.255. Okay, so 1.25 is this one. Then after that, I need to add another 5. That means I need another add another 9 at the back. 8944 plus 9 for the value of the Z, 1.255. Okay, so what do you get for 8944 plus 9? You'll be getting 8953. So you have to take 1 minus 0.8953. And then you'll get the answer 0.1047. Then usually I will just correct it to 3 significant figure and I will get 0.105. Right, so this is how we solve 3A. Excuse me. Then let's continue to 3B. Now I have a random variable of 10 pupils. Then more than 2 pupils have music lesson. If you try to read this sentence again, basically the structure of the question same as part A. Just that part A, the number of pupils are more, is bigger. But now this number of pupils is smaller, which is 10. Then more than 2 pupils, something happened to them, right? So this structure belongs to binomial still. So I'm having binomial distribution. The number of pupils is the 10, which is n equals to 10. Then having the music lesson 1 probability is still 2/5, is the same. Okay, then we are interested to find out the probability of no more than, sorry, they said no more than, not more than. Okay, no more than. No more than means that it can be 2, but it cannot be more than 2. When you want to write a symbol, it should be x smaller equals to 2. Okay, then when you're having x smaller equals to 2, that means you have to calculate the probability x equals to 0, x equals to 1, x equals to 2. So x equals to 0 give you 10C0, 2 over 5 power 0, then 3 over 5 power 10. After that, x equals to 1, it will be 10C1, 2 over 5, which is the p, power 1. Then q is 3 over 5 power 9. Then 10C2, 2 over 5 power 2. Then 3 over 5 power 8. Yeah, so it is up to and including the 2, right? So you cannot have x equals to 3 anymore because the symbol said here is x smaller equals to 2. Right, so use calculator again. By right, this answer should be a long answer for you. Then of course you have to cut it short into 3 significant figure where it should be 0.167. Alright, this is how we solve question number. We are now at question number 4. Students applying to this college take an entrance test. The student is either accepted or rejected or required to take another test. We call as retest, right, with the probability of this respectively. When a student takes a second test, the outcome and probability are exactly the same for the first test. A student who has to take a third test is accepted with the probability of 0.25, rejected is 0.75. So that means at most the student can only take until the third test, right? So draw a tree diagram to illustrate the information showing all the probability. Okay, when the student's taking the first test, the result will be having 3. It can be accepted, it can be rejected, it can be retest. I put it as retest. Okay, so the probability of accepted is 0.3, rejected is 0.2, retest is 0.5. So this is the result that we get after the first test. This is after first test. That means you've already taken the first test and this is the result that you might have. Okay, after that, for the second test that she take, or the students take, also having 3 outcome. So this retest here is the second test that the student take, okay? Right, so we're having accepted, rejected, then retest also. And from the question, it said that the probability is exactly the same. So I'm still having 0.3, 0.2, then 0.4. Okay? Then if you want it to be more precise, then this one will be actually after the second test. And this is the result for after the second test that we have. Okay, then the retest here will be the third test, alright? So when you are taking the third test, there's no longer retest option anymore. After that, you have only accepted or rejected. And the question did tell you that the accepted probability now is 0.25 and the rejected probability will be 0.75. And this is the result for the third test after the third test. Okay, so basically this is how our diagram looks like. Okay, if you didn't write out the first test, second test, third test, it's okay, right? But it's just for a better understanding only, right? But when you try to draw the tree diagram, please make sure you show very clearly all the outcome and also the probability for every single branches here. Alright, so this is what you have for part A. Then let's continue to part B. There's a part B here. Find the probability that a randomly chosen student who applied to this college is accepted. Alright, I will write my solution on top here so that you can refer to the diagram. The probability, the question asking for the probability of accepted. And you have to ask yourself, from the beginning of the tree diagram, how many pathways will show you the accepted result? Okay, so let's have a look. The very first pathway is this one. After the first test, you has been accepted, and the probability will be 0.3. This is the first case. Then we have another pathway, the second case where first time it is rejected. Rejected means no more. Okay. Another option is you might have this. For the first test, they ask you to retest. After the retest, right, you get accepted. So this is a second possible outcome. And just now is the first case, this is the second case, which is another possible cases, right? So you have to add the probability. The 0.3 is already completed case, that means the accepted case. Then plus the second possibility is this one. The second pathway here, it will be 0.5 multiplied with 0.3. You multiply the probability along the branches, but different branches, one you add them together. Okay, all right, then done. Is there any other possible outcome to get accepted after the test? Right, so I also have another option where the first test, they ask me to retest. The second test, they still ask me to retest. Then the third test, only they accept me. Okay, so for this one, multiply the probability along the branches. So you're having 0.5, multiply with 0.5, multiply with 0.25. And simplify this answer by right, you will get 41 over 80. Or the other option is 3 significant figure answer. It should be 0.513. Alright, yeah, so this is what you have for part B. Then let's continue to part C. The probability that a randomly chosen student who apply for this college takes at least 2 tests, given that the student is accepted. Okay, so to me, I think this is one of the very important keyword here, given that, and this tells you it is actually a conditional probability. Okay, and then what is the general formula for conditional probability? Usually they will tell you like this. Find the probability of event A happen given that B happened first. Okay, when you want to write the symbol, it should be A slash B. The event that happened first, you write on the right hand side of the slash. Okay, so we're having A slash B as the symbol, the special symbol for conditional probability question. And for this symbol, right, it actually has a formula. To calculate the probability, you should be taking A intersect with B divided by the probability of B. Okay, and let us try to apply in the context of this question. We are having take at least 2 tests. So I write at least 2 tests. Given that, so you put a slash. Student is accepted. Then you put accepted here. Alright. And this is the formula for the conditional, the symbol for the conditional probability. And now we apply the formula. The numerator will be A intersect with B. If I write out in the context of the question, we are having at least 2 tests, sitting for at least 2 tests, given that eventually the result is accepted one. Okay, then divided by the probability of accepted probability. Okay, so according to the definition of the conditional probability, this is the formula that we have. Okay, then let us continue and see. What is the cases and what are the possible cases that the students take at least 2 tests and also being accepted? And we have to refer back to our question one more time, our tree diagram again. Okay, I erase everything first. Okay, for all the outcome here, which one give you the idea where the students taking 2 tests or more, but finally also accepted one? Okay, so the first case will be this one. The student retest after taking the first test, then being accepted after the second test. So this is one of the outcome that you want to consider because for this case, the students already take the test for 2 times, then eventually being accepted. So maybe some of you will say that, hey, where is the 2 times? Actually, the first time is here, right? Because after you take the first test, only you have this result, either accepted, rejected, or retest. So that is the first test already. Then this is retest is actually the second test. Okay, so this actually fulfill our result where we are looking for at least 2 tests. We are having 2 tests here. Then intersect with accepted. Right? So what is the probability here? You multiply the probability along the branches. So it will be 0.5 multiplied with 0.3. Okay, so the first case I have here is 0.5 multiplied with 0.3. Then plus. Is there any other possible cases? Then you try to have a look one more time. You will realize that if I take the first test, they ask me to retest. So the retest is the second test, right? I can also retest again, then finally being accepted. So the blue color one is another outcome. Where you try to analyze it, you are taking 3 tests here. First test, second test, third test. Then finally you are accepted. Okay, so it fulfill our condition also like where we are looking for at least 2 tests intersect with accepted. So this is must be our calculation part of the solution. So you multiply the probability along the branches. So it will be 0.5 multiply 0.5 multiply with 0.25. Okay, and after that, what is the probability of being accepted? You can directly use the result that you get here in part B. The probability of being accepted is 41 over 80. So I directly use 41 over 80 here. Don't use the 3 significant figure answer, You have to use back the original value. And the best way is by putting it in the fraction form. Okay? Alright, then try to simplify all the top and bottom part here. By right, if you didn't do any careless mistake, right, the answer that you get should be 17 over 41. Or we will put it into 3 significant figure, which is 0.415. Okay, so this is how we answer part C. Alright, and then this question is a little bit tricky because of when they're talking about at least 2 tests, some students, they might not aware that, oh, actually they are having the first test here. Okay, so first test is here, this is the second test, then being accepted. Then we're having first test, second test, third test, then being accepted. Okay, so a lot of students, they might not aware that, oh, actually I'm having the first test. So they might do the wrong calculation. Alright. Okay, so please take on this. This is maybe a little bit of tricky part. Okay, right, then let's continue further. Part D. I'm having 3 friends apply the college for the college, then find the probability that all 3 are rejected. Okay, if I already calculate the probability of being accepted just now, it is actually 1, so it is actually 41 over 80, right? Okay, therefore, what is the probability of being rejected? So it is actually the opposite of accepted, where you take 1 minus 41 over 80. And now, if they are telling you that I'm having 3 friends, all of them are rejected. So that means the first friend being rejected, the probability is 1 minus 41 over 80. Second students also being rejected, so the probability also 1 minus 41 over 80. Then the third one also the same, 1 minus 41 over 80. Okay, because all 3 of them are all rejected. So you can write 1 minus 41 over 80 power 3. Okay, then again, very easily, you can get the answer 0.1158574219. And then after that, what is the correct final answer here? It will be 0.116, correct to 3 significant figure. Right, yeah, so this is what we have for the question number 4. Question number 5, we are having 2 teams here, SMART and also the teaser. There are 2 quiz teams that contain 11 members each. Both complete a puzzle and the following table give the time taken in minutes by the member of each team. These are all the data that I have. Represent this information in back-to-back stem plot, back-to-back stem and leaf diagram, where with SMART on the left-hand side. Okay, when you're having the back-to-back stem plot, I think you should know about the basic shape, right? The stem will be in the center. And then they said the SMART on the left, so I better write it out first. This is SMART. Then this part is teaser. Okay, then before you start to fill in the value, then let's have a look what is the smallest value for all the data here. The smallest value, I think, is this one, 9. The largest value, I think this is, it is 41. So that means the stem have to start from 0 first for the 9, because it is 0, 9, right? Then I'm having 1, then 2, 3, and also 4. Then you try to plug in all the value one by one into the table, the diagram by putting it as a leaf. Okay, so like SMART is 38. So you're having a 3 here, you need to put an 8 on the left-hand side, okay, on this side, right? Then of course, all your leaf must be arranging from smaller to larger value. Okay, so as an example, for SMART, I'm having 8, then 3, 8, so that means you should put an 8 here, then 3, 0, 0 here, 1, 3, 3 here, 2, 9, this is the 9, 1, 8, then 2, 2, 2, 8, 1, 8, 1, 1, 9 means 0, 9, for 41 means you put a 1 beside the 4. Then all your leaf here, this part we call as leaf, you have to make sure that you rearrange them from smallest to the largest number. The smallest number should be always closer to the stem. Alright, so I'm having 1, 3, 8, 8 for this case. Then for the row of 2, then you're having 2, 8, 9. So you should write 2 here, 2, followed by 8, followed by 9. Then 0, 8, so 0 should come first. Then 41. So apply the same thing for the teasers. Then if you don't do any careless mistake, your final answer should look something like this. Okay, then after that, don't forget about the key. You have to always write the key with the unit so that people understand what does this graph or diagram represented. Okay, right, so for the key, you can use any number that you like. So let's say, as example, I use 3/1/8. So what's the meaning for 3/1/8? It actually means that 13 minutes for the group, SMART group, for Team SMARTs. Okay, and after that, it actually means 18 minutes for the other team, which is Team Teaser. Okay, so for stem and leaf diagrams, always make sure that you did write out the key with a suitable unit. Alright, so for here, they are talking about the time, which in terms of minutes. Right, yeah, so this is what I have for 5A. Then let's continue to 5b. For 5b, now they say that for teaser, the value of the lower quartile, median, and upper quartile are this one, respectively. On a single diagram, show box and whisker plot. Highlight the keyword box and whisker plot. To get the box and whisker plot, you need actually 5 important value here. Excuse me. So you should have minimum, Q1, which is the lower quartile, Q2, which is a median, Q3, and also the maximum value. And then because they ask you to draw the box and whisker plot for 2 teams, right? So you need to have a summary of the 5 values here for each team. I'm having smart, but for the smart team, I don't know what's the value yet. But I know that for teasers, they have been given 3 important value here, which is Q1, Q2, and Q3, lower, median, and also upper quartile. So I'm having 18, 25, then 37. For the maximum and minimum, you can directly get it from the table here. So for teaser, smallest value is 12, largest value is 39. So you just put it in first. So you're having 12 minimum, then 39 is maximum. Okay, then same thing happen for the smart. Smallest value is 09, the largest value is 41. So I put in here first, 09 and also 41. We need to find out Q1, Q2, and Q3 for smart team ourselves. We are having 11 data in total, right? So where's the center? So the center means that you're having 5 value in front, 5 value at the back. So the center value here will be the median. So this median will be, okay, you're having 5 value in front, 5 value at the back. So this is actually the 6th value. So you try to count from smallest 1, 2, 3, 4, 5, 6. So this 6th value here will be your median. It is basically 22 so this is median, Q2. Then how to get a Q1? Q1 is actually the median of the first 5 number. So these are the first 5 number, right? 09, 11, 13, 18, 18. There are 5 numbers here. Where's the median of these 5 number? So the median of these 5 number will be this one. So the Q1 will be actually the median of the first set of the value, which is 1, 3. Same thing happened here. After the 2, right? After the median, you are still having 5 numbers at the back. So median of this second half of the data will be the Q3. Where's the median again? 1, 2, 3. The third value here is the median. So your Q3 will be actually the 30. Okay, so Q1 is median of the first set of data, the first half. Q3 is the median of the second half set of the data. Alright, so I'm having 13, 22, and 30. Then I put it in our summary here. I'm having 13, 22, then 30. And now we can start drawing the stem plot, okay, the box and whisker plot. Okay, so for this box and whisker plot, you need to know that the scale is still important, the ratio. So I'm having the x-axis in the horizontal line. Okay, so you can draw it nicer. Okay, maybe I enlarge it first. Okay, so if you try to observe all the value here, right, basically you can see the smallest value is a 9, the largest value is 41. Then I just need to make sure that my scale can fit in all the values. So I start from here, 0, 10, 20, 30, then 40. So 41 is just one box after this, so it should be enough, right? Okay, then we will label it as time in minute. Okay, so once you settle down all the scale here, then you can try to plot, put in all the diagram already, put in all the value. So let's start with the smart first. Minimum value is a 9. So at 9, you try to draw the number line. 9. Okay, then Q1 is 13. 10, 11, 12, 13. So you draw a line as well, 13. 22, so 20, 21, 22. Then 30, 30 is this one. Then 41 will be this value. So you can see that I draw the 5 line here according to the ratio that I set. After that, Q1, Q2, and Q3, you need to draw 2 horizontal lines to make it as a box. So this one you call as a box. Then for the whisker, you try to draw from minimum value to the box and also from the box to the maximum value. Okay, and then this is for the group of smarts. So you have to label them clearly. This is the smarts group. Okay, apply the same thing for teaser. So for teaser, we are having 12 as a minimum value. 10 is here, then 11 and 12. Okay, then 18. 20, 18 is here. Q2 is 25. Then Q3 is 37. And not Q4 anymore. The maximum value is 39. So this is 40, right? 40, then 39 will be somewhere here. Okay, then again, for Q1, Q2, and Q3, you have to draw two horizontal lines to make it become a box. Then you join whisker with the box, but they have to make sure that the line cannot cross the box, yeah? You'll be just touching the box outside. Okay, so this is for the group of these. Yeah, and this is how we actually construct the box and whisker plot. Okay, then let's continue further. Now they want you to make two comparisons between the time for the two teams. Every time when they want you to make any comparison, right? If let's say one comparison, then usually we will comment on central tendency. If let's say both, then you have to comment on central tendency and also the spreadness, right? Okay, so you have two comparisons here. First of all, let's have a look for the box and whisker plot. Which one do you think that generally the score are, the time is shorter? So I think the smart team will be having the shorter time because you can see the majority of the box, right, is on the left hand side compared with this one. Okay, so the very first comment that we can do is the smart team are faster. So faster means that you're looking at the overall, the graph, right? Overall, it is on the left, lah, compared with the other group. Therefore, the smart team are faster. And for your information, this is basically the comparison on central tendency when they're talking about the mean or the average tendency. Okay, and now we need to have the second comparison, which team give a more consistent time. Then we are looking at the spreadness of the box. So this box looks spread wider compared with this box which spread smaller, right? You can also say in this way where smarts time are more consistent. In other words, more consistent also means less spreadness. So less spread. And this is a second comparison. This second comparison, basically we are talking about the spreadness. Okay, so every time when they ask you to comment or maybe make comparison for two, there are two comparisons that you can maybe tackle in this way. One comment for the central tendency, another comment for the spreadness. Okay, the measures of variability. Okay, but we look at the box, the spreadness of the box. Alright, yeah, so this is how we solve question number 5. So the last question for this paper, there's a dart club with 12 members, right? Then there are 7 men and 5 women. Okay, so every Monday a team of 4 is chosen at random to represent the club in a competition. So we usually need to form a team and the team has 4 members. Find the probability that on a particular Monday the team consists of 1 man and also 3 women. And they are interested for the probability. Okay, when we want to choose someone, okay, to form a team, choose means selection. So selection basically involves combination, right? And to calculate the probability, the general formula is the total number of restriction, the combination with restriction on top, on numerator, divided by the total number without restriction at the bottom. Okay, so what is the restriction given in this question? They say that the restriction is 1 man and 3 women. The gender is a restriction. Okay, they restrict that this team must have 1 man and also 3 women. So to select 1 man from the total of 7, it should be 7C1. But 7C1 is not a complete team yet, right? To make the team complete, you have to multiply the combination of the women as well. So I want to have 5C3. 5 women, I want to choose 3 of them. Divided by the total of the combination without restriction for denominator. But what should I put here? So now you don't think about the gender anymore. You just how to say, get the value by looking at the overall. So I'm having overall 12 members. Then I want to choose 4 of them to form the group. And it will be 12C4. This is a number total combination without restriction, right? Then after that, you just need to simplify it by right. You'll be having 14 over 99. Okay, or if you want, you can put it into 3 significant figure, 0.141. So this is what you have for part A. Then let's continue to part B. Now they said every Tuesday, the club choose 3 teams of 4. Just now you choose only 1 team, right? You form only 1 team. But now I want to have 3 teams already. Each team enters a competition in a different town. Every single team, they will be sent to the competition in different town. In how many different ways can the team be chosen if there are no restriction? Highlight the keyword chosen again. Alright, to form 3 teams, what are the combination here? So we try to select team by team. Okay, for the first team, you want to have 4 members, right? You're having 12 members in total, and you want to choose 4 of them and form the first team. So it'll be 12C4. Okay, and after that, multiply with how to get the second team. So to get the second team, you take the remaining 8 person and you want to choose 4 of them to form the second team. Right? And for the third team, remaining 4 person, you want to choose 4 of them to form the third team. Okay? And then what is the total for them? It should be 3, 4, 6, 5, 0. Right? Yeah. And then this is for the cases when there's no restriction because we don't actually look at the number of men or the number of women in the group. Okay, we just only focus on the number of members only, right? Yeah. Then let's continue to part C. Now continue with part C. They are asking, in how many ways can the team be chosen? Again, highlight the keyword chosen. It is a combination still. If each team must contain at least 1 man and at least 1 woman. Okay, yeah, so how can we get at least 1 man and at least 1 woman? So this one will be a bit more complicated because they started to introduce in the restriction. Okay, so maybe we need to list out all the possible cases, yeah? Okay, for case number 1. Okay, for case number 1, because we are having 3 teams, right? What are the possible cases if we have at least 1 man, 1 woman in the team? So let's say I'm having team number 1. Then I have team number 2. Then I have team number 3. Okay, and for team number 1, maybe I try to fix, because we are having 7 men and also 5 women. And then each group must have at least 1 man and 1 woman. Maybe I try to fix the number of men first. Okay, for the number of men, I can set 1 man here, 1 man, then maybe separates equally for the other group 3 men and 3 men. Okay, alright. Then how about the women? So if let's say this is 1 man, for this group it must be having 3 women. Then for the other 2 group, it must be having 1 woman and also 1 woman. So you can see that for the total of the 3 teams here, right, it is nicely divided with at least 1 man and at least 1 woman in the group. Okay, then total of the woman is 5. Then the total of the man is 7. Okay, so this is the first possible case that I have. Alright, then maybe we have some other cases. Let's think about it. How about if let's say I set the first group with the 2 men. Okay, so if let's say first group with 2 men, then what is the other possible number of men in team 2 and team 3? So if let's say I'm having 2, maybe for second group I also fix it as 2 men. then the third group I fix it as 1 man. Oh, sorry, 2 plus 2 is 4, right? Then the third group must be having 7 men. Sorry, 3 men, so that the total equals to 7. Alright, after you fix the number of men already, then now what do we have in the group, in the team 1 for the woman? It must be having 2 women, so that the total member is a 4, right? Then for team number 2, also 2 women. For team number 3, it must be having 1 woman. So if you try to double check, the total woman is still a 5. Then the total man is still a 7. And then it fulfilled the condition where we must have at least 1 man and also at least 1 woman. Okay? Then now you can try to fit in some other value. Let's say for the third case, if I have 3 men, can I have 3 men? Then this one I have 1 man. Then this one must be 3 men. And you realize that this result is basically the same as case number 1. Alright? Yeah, so no matter the 3 men, 1 woman in which group, okay, it still belongs to the same result in team in case number 1. Alright, so this case we no need to include it. Same thing happen for the number of men. Okay, let's say some students, they say that, okay, I want to try out 4 men, can or not? 4 men in a group. If you want to try out 4 men in a group, then maybe this is 2 men, this is 1 man. But again, when you are having 4 men in the group here, you cannot fit in any woman. So this doesn't fulfill the condition of the question, right? Because the question asking for at least 1 man and also at least 1 woman. But if you try to consider this case, it is basically not in our consideration because it didn't fulfill the request of the question. Alright, and that's why from here we know that, alright, these are all the possible cases according to the question request. Alright, then now let us try to figure out what are the combination that we have for team 1, team 2 and also team 3. Let us start with team 1 first. Okay, for team 1, we are having 7 men in total originally. So I have 7, then I want to choose one of them to put in team 1. Then I have 5 women originally. I want to choose, so maybe I try to put it in different color, easier for you to visualize, yeah? Okay, then for women, I'm having 5 women originally. I want to choose 3 of them and put it in the group. Okay, then for team 2, I still have 6 men left. I want to choose 3 of them and put it in team 2. Then for the woman, just now I already choose 3 out, right? I left 2 women only. I want to choose 1 of them and put it in the team 2. Okay, then for team 3, I still have 3 men remaining. I want to choose all of 3 of them to put it in team 3. Then for the woman, I left only 1 woman. I want to choose the only woman and put it in team 3. So this is how we select the team according to the gender. Alright, and what should we do to complete the case? So like what I told you earlier, when you want to calculate the combination within the case number 1, by right you should multiply them. Therefore, for team 1, team 2 and team 3, to get the number of combination, you have to multiply them because all of them are within the first case. Alright, so you multiply the number of combination. But if let's say you are talking about case 1 and case 2, later you take this total and this total and this one, you have to total them. You total the combination between the different cases. This one is within, right, in a case. So in a case means multiply. For the 2 different cases, then you add later. Alright? Okay, after that, for this question, after you select the group and you form the team, right? Let's read the question one more time very, very carefully. They actually did mention that every Tuesday, the dart club choose 3 teams of 4. Each team enter a competition in a different town. Alright, what does it mean? That you are having the competition in a different town. That means for team number 1, you might go to town 1 or town 2 or town 3 for competition. Then this one also the same. You might go to town 1, town 2 or town 3 for competition. Same thing happen for this. Alright. Therefore, you need to consider the possibility of putting the team into the different town. Okay. But if you have a look for the cases that we have here, we are having 2 groups with 3 men and 1 woman. Okay, 3 men and 1 woman means that when I send 3 men and 1 woman to town 1, and I send the other 3 men and 1 woman to town 2, right? The outcome might be the same. So we consider this as an identical case. Therefore, you have to take 3 factorial. 3 factorial means that you are trying to rearrange the 3 team here into 3 different towns. So 3P3. But because of I'm having 2 identical team, right? Okay, with 3 men and 1 woman, therefore you have to divide it by 2 factorial. Then when you try to simplify this part, by right, you will be having 8,400. This is what we have for case 1. Alright, so you can see that it is a bit complicated because at the first part, you need to select the team first from 12 members. After that, you have to consider how are we going to assign the team into the city for competition. Alright, okay. Yeah, so this is why we need to consider the arrangement for the town. And also because we are having the identical team, therefore I have to divide it by 2 factorial. Alright. Okay, then let's continue to the second case. Same thing happened here. For second case, let us select the member first. I'm having 7 men originally. I want to choose 2 of them and place it in team number 1. For women, I have 5 originally. I want to choose 2 and place them in the team 1. After that, I have 5 men remaining. So 5 men, I want to choose 2 to place them in team 2. How about for the women? You have 3 women now left, 3 women left, and you want to select 2 of them and put it into team 2. Then how about for the third team? You have 3 men remaining. You choose all of them to put it in team 3. Then the women is, you are having 1 woman left, then you choose this woman and place her in the team 3. And again, this is within the case, right? Case number 2. Therefore, you multiply the number of combination. After that, again, the same thing happened here. We still need to consider how are we going to assign the team into the city. We are having 3 teams assigned to 3 cities, should be 3 factorial. Arranging the 3 teams into the different city, right? But because of we are having identical team also here, 2 men, 2 women, 2 men, 2 women, according to the gender, right? And that's the reason why you need to divide it by 2 factorial again. Okay, then from here, what do I get? I'm having 18900. So these are the 2 possible cases for us to assign the team. Okay, and after that, what is the final answer for these 2 cases? You have to total them up. So when you total them, by right, your answer should be 27300. Okay, so this is what we have for part C. And before I forget, right, this question to me, I think is quite tricky as well because I remember that there's one question very similar to this question for May, June 2025. So I tried to figure it out and check. I realized that there's one question very similar to this one. Maybe we can discuss it together here so that you can make a simple comparison about these 2 questions. Okay, so this question is actually, I put it beside, then you can try to compare them. Okay, if you are free, you can have a look for this particular question as well. It is actually from May, June. This is May, June 2025, paper 5-1. And it is question number 5, part B. We are having very similar question here where they are saying that we also form 3 bands from the group of 20 musicians. But for these 3 bands, they already fixed the number of musicians for you, for each group. So every group must have 3 guitarists, 1 pianist, 1 drummer. Therefore, you can see that we are having group 1, group 2, and group 3. And the number of combination here, right, is the same like what we did here. This is team 1, team 2, and team 3. So the team 1 is like our first group. Team 2 is like our second group. Then the team 3 will be like our third group. Then to get the combination, I just multiply the combination within the group. Okay, this is the first case. But for this question, because they're only asking for first case, that's why we only multiply the combination, but we didn't have second case to be added. Okay, but the difference is if you try to have a look in detail, right? For our question in this year, I actually need to consider the arrangement for the team to the different city. That's why we are having the 3 factorial divided by 2 factorial. But if you try to have a look, For this one, right, you realize that they are saying that the first band selected will play a concert in France. So only the first band is going to be French. So that means now we no need to consider the arrangement for different country, because they already tell us clearly that this group go to this place, second group go to Italy, third group go to Spain. So there's no consideration about the arrangement, like how to assign the different group into different country. Therefore, for this calculation, there's no arrangement part at the end here. But for this one, we are having the arrangement. Why? It is because of they tell us that in the questions, they are saying that, okay, for each group, they will enter a competition for different town. Okay, but they didn't tell us clearly that which group go to which town. So that means it has a possibility that you need to consider the different town assigned to the country, assigned to the group, sorry. All right, so that's a small difference between this question and also this question. But to me, they have similarity because of the way of choosing the member to form the group. Okay, just that this one, they have fixed every single group to a fixed country. Therefore, no need to consider the arrangement for the country. For this one, we have to consider this 3 factorial divided by 2 factorial, because of for every single group, you need to assign them to different country that's not fixed yet. So you need to consider all the possibility for each group to each country. Okay, so I hope that you know a little bit, you know how to compare and how to solve these 2 questions here. They have similarity, but they also have a small difference between them. All right. Yeah. So to me, this is one of the to me, it is not an easy question. Okay, so I realized that when I'm trying to solve this question, there's a little bit of confusion for me. So I hope that I can clarify your doubt between this and also the question from year 2025 paper 5.1. Okay, yeah, so if you're free, you can have a look again for this particular question here, right? Yeah. All right, then next one. Now we are having the part D. There are 7 men stand in a line for the photograph. 2 of them are brothers, George and also Harry. Okay, so the 7 men now want to stand in the line for photograph. Only the 7 men, not included the women yet. Okay, so how many different arrangement? Highlight the keyword arrangement. Are there of the 7 men in which there are exactly two men between George and Harry? Okay, for this kind of question, usually I prefer to write out the possible location for George and Harry first. So let's say I'm having George, I'm having 2 person in between of Harry. So you have 4 person now, 1, 2, 3, 4, then 5, 6, 7. These are the 7 men here. 2 men between George and Harry, right? It is possible also that George and Harry can be having this one. That's the second position. Then the third position for George and Harry will be this. Then the last possible position for George and Harry will be this one. Okay, so from here, you can see that there are 4 possible cases for us to place George and also Harry. Therefore, I multiply with 4 first. So the 4 here basically means the 4 cases here. Okay, all right. And after that, because George and Harry, they are 2 different persons, right? You can actually exchange their position. It can be also Harry here, then George at the back. Therefore, you have to multiply with 2 or 2 factorial because of the position for George and Harry. So if you need some explanation, then you can just put a small note for yourself. Okay, the 2 here basically means George and Harry can exchange their position. The 4 here basically means the 4 cases here. Case number 1, case number 2, case number 3, and also case number 4 for George and Harry. Okay, after that, you can arrange all the remaining men freely. How many men are there? 5 men, right? So you can arrange them freely, which is 5 factorial. Therefore, you're having 4 times 2 times 5 factorial. And by right, you should be getting 960 for this question. All right. Okay. Yeah. So this is the very last question for this paper. Okay. Thank you very much for watching the video.